Hello everyone and welcome again to the problem number of distinct values. This time we will see how to solve this problem in linear time complexity. What we are going to do is first to remember our little brute force approach and then see how we can optimize that solution using the knowledge that we have now. In that brute force approach, we have iterated through each element in the nums array, and then we have checked if that was the first occurrence of that specific value, and if so, we will increment our answer. If not, it means that we have already counted the number into the solution, so we do nothing. Iterating through the elements of the nums array, of course, is going to take big O of n time complexity, so we are left only with constant time complexity to figure out if that's the first occurrence or not. So for each element in the array, let's take this -4 as an example, we have to check in constant time if that value occurs in the subarray or not. So what we need here is some kind of collection or data structure which supports looking for an element in constant time. And now we know that this data structure could either be a frequency array or a hash table. As the elements of this array could be huge and also negative, of course, we are not going to use a frequency array, but a hash table. And the beautiful part of this solution is that whenever we want to check if some value has already been encountered, we have already iterated through these values. So we can have a hash table which is going to store the previous elements that we have iterated through. So for each element, we will first check if that value occurs in our hash table, and if not, increment our answer, and then also insert that value into the hash table and move on. Let's see how this works on our example. Our hash table, which I named values, is initially empty and the answer is initially 0. Now, I iterate through the first element, 1, and I see that 1 is not part of the hash table. So what I'm going to do is, of course, increment the answer, as this is the first occurrence of the value, and then also, to use it in the future, I'm going to insert this value in our hash table. And as we know, in a hash table, we have pairs of keys and values. So I know the key is going to be 1, but what's going to be the value? Well, it's actually not important. I can have something like a pair consisting of the key 1, and let's say the value is true, just to denote that, alright, the value 1 exists, but also this could have been anything else. It could have been even a 0, or it could have been a character, let's say X, or anything. Because what we really care about is whether this key exists in our hash table. We don't care about its value, right? So what you should know is that the programming languages took this scenario into account, and they have designed a particular version of the hash table, which is called the hash set, in which we won't store pairs anymore, but only number, which are the keys. So I'm going to call this a hash set. In JavaScript and Python, it is actually a set, but in Java, for example, it is a hash set, and in C++, it is called an unordered set. And in this hash set, because we don't deal with the pairs anymore, you should know that you won't be able to access some pair in the hash set like we did, for example, in the frequency array or on the hash table, where we have said the name of the hash table, values of some key, and this expression would have returned us the value, right? You can't do that anymore because obviously you don't have pairs. All you can do is insert one element and try to find that element using built-in functions. If you remember, in a hash table, we weren't able to have two pairs with the same key. This is also true for a hash set, but because now we don't deal with pairs anymore, but only with their keys, which are the elements in this hash set, you should know that you are not able to have duplicate keys in the hash set. The only exception for this is C++, where you actually have another data structure which is defined by the language, which is a multi-set in which you can do this. But in all the other languages, you don't have this, and trust me, you won't need it. So getting back to our example, what I'm going to do here after incrementing the answer is just insert the value 1 in my hash set. Now this is our hash set values. Move to the next value, which is 5. Try to find 5 in our hash set. It doesn't exist. Increment the answer again. Now the value is 2. And of course, we are going to insert 5 into our hash set. So now we have 1, 5. Guess what? -3. The exact same thing. -3 is not part of the hash set. We increment the answer again. It is 3. Then we insert 3 into our hash set. Move to the next element, which is 1. And this time, as you can see, 1 exists in the hash set. So we do nothing. And indeed, this is its second occurrence, so we shouldn't count it. And of course, when now we try to insert this 1 into the hash set, this won't happen. You won't get a runtime error or something like that, but it simply won't happen. The computer sees that the value 1 is already there and it won't add another 1. So the hash set stays the same and we continue the algorithm. Now you can imagine what's going to happen for the next values. Let's not waste time on those and take a look at the code. And that's it, as simple as that. As you can see, I first declare my hash set, which is named values and is initially empty. So again, do your homework and check online. You are going to find a lot of articles, even the official documentation. What is the exact data structure for this hash set in your specific language? Then we have a variable which is initially 0. Then we iterate through each number in the array nums. Then we check if that number is not part of the values hash set. So again, for this, you have, for example, in Python, if num not in values, I think that's it. Maybe in JavaScript also. In C++, for example, you'll have to check if values.find of num is not equal to the end iterator. So C++ is a little bit more complicated, but don't worry about it. It's part of your assignment. Check it online and see what is the exact syntax. You can do this. And if num is not part of the values hash set, so this is its first occurrence, what I'm going to do, of course, increment the answer and then insert that value into our hash set. And that's it. After iterating through all the elements, we will just return answer. Now, what is the time complexity of this algorithm? Well, declaring an empty hash set is, of course, constant. This is constant. Now, what we do inside the for loop, inserting in a hash set or a hash table is constant. We know that. Incrementing a variable is constant. Lookup in a hash table or a hash set is also constant. Returning this is constant. And we do all of this for a total of n times. So our final time complexity here is going to be big O of n. Now this is definitely faster than all the other solutions, but there is a price we pay for this time complexity, and that price is the space complexity. Now, how many elements will we insert at most in our hash set? Well, let's think of the worst case scenario in which all the elements in our array nums are going to be distinct. In that case, each and every element is going to be inserted once, of course, in that array. So we will have at most n elements here and integers. So our space complexity is also big O of n. So it really depends on the context, right? Big O of n is not a lot faster than big O of n log n, but it will use big O of n space memory. You will have some scenarios in real life in which you will want to sacrifice the memory for a faster approach, or where you will want to sacrifice the time complexity, the speed of the algorithm in order to save more memory. And that's it, guys. I hope you enjoyed this lesson, and I'll see you on the next one. Bye.